Here's a truth that should embarrass every data engineer a little. Getting data from one place to another should be trivial, and yet somehow, it almost never is. Let me take you back to 1431. A merchant named John Beer is trying to do something simple: trade cheese and quicklime between Hampshire and London. Straightforward commerce, right? Except the weights are different depending on which county you're in. The currency denominations shift. Even the dialect used to describe what he's buying and selling changes as he travels. Every transaction requires a fresh negotiation just to agree on the basic terms. John Beer isn't struggling because trade is hard. He's struggling because there's no shared framework, no standardization, no common ground. Now fast forward 600 years. Replace cheese with JSON and quicklime with CSV exports. Replace dialects with API schemas and currency denominations with conflicting timestamp formats. The problem is almost identical. And the reason it's still with us, still frustrating data engineers every single day, is the same reason it was frustrating John Beer. The problem isn't technological, it's human. Entrenched habits, local conventions, teams that have always done it their own way. The Magna Carta tried to standardize weights and measures in England. It took until the Weights and Measures Act of 1824, more than 600 years later, for that to actually stick. Organizational resistance to standardization is ancient and stubborn. So what do you do in the face of that resistance? You stop building pipelines and start building frameworks. That's the shift worth making. Not a pipeline for each data source, each shaped by whoever happened to write it that week, each requiring its own custom monitoring and validation logic hand-stitched in. Instead, a principled, repeatable framework that any new data source can plug into. Build it once. Get the hard thinking done once. Then let every new connector inherit the structure for free. Here's what that framework looks like at its core. You extract, you validate, you transform, you load, and you monitor. That's the spine. Simple to say, genuinely difficult to do well, but the discipline pays for itself quickly. Start at the beginning. Extraction. When you pull data, from a scraper, an API, a database dump, whatever the source, your first and most important move is to save the raw file immediately. Don't transform in place. Don't clean as you go. Land that original data somewhere in your data lake and treat it as sacred. Never delete it. Never mutate it. Because when something breaks downstream, and it will break, you need to be able to go back to the source, replay the process, and debug from a fixed point. If you've transformed in place and something went wrong, you've lost your reference. You're debugging fog, and separate your extraction step from your transform and load steps. Physically separate them. A failure in the extract phase should stop there. It should not silently allow a half-formed, gapped dataset to trickle through into your transformation logic and end up in front of a stakeholder who has no idea it's incomplete. Fail loudly, fail early, fail in the right place. Now, validation. You need 2 checkpoints, not 1. The first happens at ingestion. Is the schema what you expected? Does the structure match? Are the columns there? Are the types right? Does the row count look roughly sensible? This is your structural check. It's mechanical, and it can be automated completely if your connectors are built right. The second validation happens later, in a staging table, before the data gets promoted to the consumption layer. This is where you apply business logic. Is this date range plausible? Are these revenue figures within expected bounds? Does this customer record actually resolve to a real entity? These checks require context. They can't be automated in quite the same way, but they are just as important, because they're protecting the people who will actually use the data from having to do the validation themselves. That's the goal. The end user should not have to validate the data. If they have to check whether the data is trustworthy before they can use it, you haven't finished building the pipeline. You've just moved the work onto someone else. When validation fails, the answer is to stop the data flow cleanly. Not to pass through partial data with a quiet warning buried in a log somewhere. Stop it, and critically. The stakeholders who depend on that data need to know what the policy is. Are you stopping the flow and sending an alert? Are you backfilling when it recovers? Are you passing through what arrived with a flag? Any of those policies can be defensible, but only if everyone who uses the data understands which one is in play. Silent partial failure is the worst possible outcome. Keep your pipeline acyclical. Data flows in one direction. That's not a preference, it's a principle. The moment you introduce a circular reference, where database A writes to B, and B informs something that writes back to A. You've destroyed your single source of truth. You no longer know where data originates. You can't audit it. You can't debug it reliably. Draw the flow as a directed graph and make sure there are no loops. If you find loops in an existing system, refactoring them out is worth the pain. Minimize nodes. Every additional system, every intermediate hop, every extra storage layer is another potential failure point. Fewer nodes means fewer bugs, simpler monitoring, and faster diagnosis when things go wrong. The instinct in data engineering is often to add a cache here, add a processing layer there. Resist it unless you have a clear, specific reason. Simplicity is a feature. Now, what is all of this in service of? A data warehouse that actually works like a good library. Think about what makes a library valuable. Two things: variety and trust. If a library only has books on one subject, most people won't bother going. And if the books are misfiled, damaged, or randomly missing pages, people will stop trusting it even if the variety is there. A data warehouse needs the same two things: broad coverage, finance, operations, marketing, product, external sources, so that when someone has a question, there's a reasonable chance the answer lives there. And trustworthiness. Data that arrives when expected, in the form expected, that consumers can pick up and use without first interrogating whether it's reliable. That's the data as product mindset. When you go to a supermarket and pick something off a shelf, you trust the label. You don't open the packaging to verify the contents. You rely on a system of standards and accountability that means the label is accurate. Data consumers should be able to do the same thing. Find the dataset, read its documentation, and use it. The pipeline behind it is your responsibility, not theirs. Build reusable, configurable connectors for each source type, databases, APIs, FTP, S3, whatever your stack involves. Write them once, properly. When you add a new source, you should be configuring, not rebuilding. Monitoring and validation should emerge from the framework automatically, not be hand-coded for each new pipeline. Use orchestration tools that give you step-level visibility so that when something breaks, you know exactly which step broke and why. The feeling that data engineering should be trivial, that we're just postmen for the internet, getting data from here to there, is both right and a little naive. It should be trivial, in the sense that the framework should make each new job feel easy. But building the framework that creates that ease is serious, careful work. Do that work once, do it with principles, and the trivial feeling will actually arrive. The real job of a data engineer isn't to move data, it's to build the conditions under which data can be trusted.